What is up, people? It is the Polygons review worksheet. All right, we're going to get into this one a little late here, so this is a review, a little bit of triangles, some stuff that didn't come up on the review sheet last time, some extra questions, and then we'll get right into the polygon stuff. So, first one, points of congruency to the triangles. So, remember, concurrent means two or more lines that cross at the same point. So these lines are all intersecting at the same point, and there's four of them. There's the perpendicular bisectors. That makes the circumcenter. So whenever I remember this as PBC, peanut butter cheese, whatever you want to say, PBC though, perpendicular bisectors form the circumcenter. This one is the Abe in. That's where Abe Lincoln sleeps. So the Abe in, A, B, and then I, N. Abe in, right? Angle bisectors form the incenter. The medians, for you fans of video games or Smash Brothers here, would remember the Samus, who is a character from the game Metroid. So medians make the centroid, or if you want to think of a Metrobus on steroids, Metroid. And then the altitudes in the orthocenter, and if you remember AO, like you see your friends over there, and you're like, AO, right? These are the ways that I use to remember them. There's a couple other sayings I've heard along the way, so you can kind of keep that. If you get one of those, I'll bring it up in class. You don't have to know these so much, but the incenter and the centroid are always found inside the triangle, and the orthocenter and circumcenter are found in either inside, if it's acute, on the triangle, if it's right, or outside when it's obtuse. So you really just need to know when we talk about the names, what lines form them. So the circumcenter, perpendicular bisectors, angle bisectors are the incenters made by the angle bisectors. Centroid is the medians. Orthocenter is the altitudes. The only other part of this is the centroid, is that the centroids, when these lines cross, this line here is twice as big as this side. That's the only really property that you got to know so much in this. The circumcenter lets you draw a circle on the outside, circumscribed. This one lets you draw a circle inside, inscribed. Okay? Those are really the only key things going on here. So take a look at some questions. These are from practice tests that they gave out, not from the state, the Green Review Book Company. So the first one, number 6, perpendicular bisectors to the sides of the triangle. Which point of congruency drawn? Remember the PBC, and that's the circumcenter. For number 8, what point of congruency is the medians? Remember, medians is metroid. That's the centroid. Number 10, if a circle is circumscribed about a triangle, its center is located circumscribed around the outsides. Remember, that's PBC. That's the perpendicular bisectors. That's going to be choice 2. And then, so that's essentially what we're looking for there. It could come up in constructions if they ask you to do it, but the question hasn't been asked that way. Doesn't mean they won't, but you know, just keep that in mind. All right, largest side of the triangle is across from the largest angle, and the smallest side of the triangle is across from the smallest angle. We talk about giving big hugs, right? You got to open your hands real wide, create a wide angle to give big hugs, right? Small hugs is a small angle. So if the side between them is real narrow, that means the angle formed is going to be small, and if you make the side bigger, the angle's got to be bigger. So in the first question, the diagram of triangle ABC with side AC extends to D. This is also an exterior angle question. BCD is 117. Which side of triangle ABC is the largest? Okay, so if you remember, the exterior angle theorem says that angle A plus angle B, these are called the remote interior angles, which are called by themselves, has to add up to equal angle BCD. So you could just do 117 minus 37. That'll get you here. Or you can use the fact that you're going to do a linear pair and then use that angle here to get angle B. So a couple options. Just wanted to walk through some of the vocab going on here, but that's about it. So let's do the 117 minus 37 because we're crazy like that. And this is 80. So this is the measure of angle B. And if you wanted to, we could do 180, 80, minus 117. That's the other method that would have come up here the most. This is 63. And then if you add these two together, right, you're going to get 100. So that's another way to get this one. Now, which of these is the longest? So which angle is the biggest? That's B. So that means AC is the longest, not longest, right? Side, comma, across from the largest angle. All right. Okay, the next one, shown the diagram of triangle ACD below. B is a something. All right, we'll try to figure that one out, right? If angle A is 66, angle BCD is 18. This is 24. What is the longest side of triangle ABD? So we don't need to know what B is. B is annoying because I don't know what this word is. You can figure out just from what's going on here that if this is 18 and 24, you can get this guy, which means you can get this guy, you can get this guy, and then you can answer the question of which is the longest. So remember, you need to know all three sides for the most part to figure out which is the longest. Unless one of the angles is obtuse or right, then that guarantees we know. So if this is 24 and 18, we can add those together if you'd like and do another exterior angle theorem here, right? And get that this angle is 42. If you had added these two together to get 42, you could have done 180 minus that, okay? That's 138, and that would give you the measure of this angle, and then you can kind of go from here. So 66 plus 42, if we add them together, it's 108, and then 108 minus, 180, right? 180 minus 108 would give you the measure of the other angle, which is 72. So largest angle 72, across from it is the largest side, and that would make that 80. Okay, awesome. On to page 2, the triangle inequality theorem. Remember, any two sides of a triangle need to add together to be larger than the third side. It just doesn't really need to say smaller. Any two sides of a triangle always add together to be largest. Okay, so for instance, if we take triangle A, B, C, that means if I take A, well, let's go lowercase. Here's side A, side B, and side C. So side A plus side B has to be bigger than side C. A plus C has to be bigger than B. And that means that B plus C has to be bigger than A. Those are the three inequalities we kind of work with here. Now, the trick is that if you want to know if they give you any of the two sides and you want to figure out, well, we'll talk about when we get to this question. Which numbers could represent the lengths of the sides of a triangle? So if you just add these together, like is 3 plus 6 greater than 8, right? Now, you only have to really check the two smallest. I guess that's why smaller is on there. Because you know that x plus 6 is bigger than 3. 8 is bigger than both of these. So when I add 8 to either of these, it's still going to be bigger. Okay? So we want to know is that going to work? Right? Is 1 plus 2 going to be bigger than 4? And is 7 plus 7 going to be bigger than 15? Is 5 plus 9 going to be bigger than 14? So if we just check the two smaller sides and add up to be larger than the third, that's an easy check. So here we can figure out the answer is just going to be 4 because this is 9, which is bigger than 8. All right. Two sides of a triangle have lengths of 4 and 10. The third side should be. Now, if we just call the third side x, so let's say they have 4, 10, and x, right? 4, 10, x. Not drawing the scale, obviously. That means if we do 4 plus 10, it has to be bigger than x. 4 plus x has to be bigger than 10, right? And 10 plus x has to be bigger than 4. Now, if you just solve for x, this is going to turn into that x is greater than 10 minus 4. I'm not going to subtract it yet. I just want you to see this. And this one is going to say that x is bigger than 4 minus 10. Now, this is going to be negative. So this is a no duh. This side has to be bigger than some negative number, right? So to get the range of numbers, all you have to do is take the sum of the two sides they give you and the difference of the two sides they give you, and that gives you the range of numbers that the side has to be in between, right? Keep in mind, the third side can't be 14, so it has to be like less than 14, and it can't be 6 because then it won't be bigger than 10, right? So it has to be greater than 6. So if you just add the two sides and subtract them, that'll give you the numbers that you're looking in between, right? Those are like the goalposts. It can't be right there as long as you're inside of them. So if you just do 10 plus 4 and then 10 minus 4, right, that gives you the numbers that you have to stay inside of. So which of these numbers is less than 14 and greater than 6? And we know it's choice 1. All right. For the fill in the blanks, I'll leave this for you guys here. You can just pause it, copy this down if you had a chance. Ready, set, pause. I said pause. No, press the button, tap the screen, but there we go. Okay. Now, trapezoid really just has one set of parallel sides. We talked about in class, you can kind of also show the other sides as not parallel, but really this is enough to show us a trapezoid. An isosceles trapezoid has the non-parallel side, which we call the legs, congruent. The base angles are congruent, and the diagonals are congruent to each other as well. In parallelogram, there's really 6 properties. This guy right here is really a combination of these two. So its opposite sides are congruent, opposite sides are parallel, the diagonals bisect each other. One pair of sides are congruent and parallel, the opposite angles are congruent, and consecutive angles are supplementary. Okay? These are usually the ones we use for our proofs for the most part. When we talk about coordinate geometry stuff, which we'll do tomorrow. And these guys come up sometimes, but not a lot in the coordinate geometry proofs. But they still need to know them for the properties questions, which we're going to do a little bit later. The rhombus, remember the diagonals are perpendicular, all sides are equal, and the diagonals bisect the angles. And a rectangle, all the angles are 90 degrees or right angles, and the diagonals are congruent. Sometimes we say consecutive perpendicular. The square is just a combination of all this and all this, those 5 properties put together. Okay, so you can kind of fill it in for yourself. So, on to the next page. Number 14. Now, once again, these are just cut from different practice tests, so that's why the numbers are just kind of bouncing around here. So, which statement cannot be used alone to prove a quadrilateral is a rectangle? So remember, what are the 2 things rectangles have, right? They have 90-degree angles, and they have diagonals that are congruent to one another, okay? So, a parallelogram, in general, has those 6 properties going on, okay? So, any one of these would not be enough. We have to have one of these 2, okay? So the quadrilateral is a parallelogram with congruent diagonals. That would be enough. A parallelogram with a right angle. That would be enough. Pairs of opposite angles that are congruent. Remember, every parallelogram has that, so that wouldn't be enough. And all the angles being right angles. That would be enough. So this we would want to choose choice 3 because we cannot be used alone. Okay. Number 8. The diagonals of a parallelogram are not congruent, and they bisect the opposite angles. The parallelogram must be, and the key thing here is it says bisect the angles. So what shape does that? Remember, that's a rhombus. Okay, so you can go through that one. Kite, we really haven't talked about that much. It doesn't really come up. It's not in our curriculum. But if you draw a kite, the only property is that there's 2. They're not opposite anymore, but the sides are congruent. Okay, consecutive sides. There's 2 sets of consecutive sides congruent. And then the diagonals essentially are perpendicular and form right angles, okay? And this one actually gets cut in half. But this question is not going to come up on the exam. It's not in our curriculum. They're not going to ask it, but just want you to see the property. So if you kind of picture like the old school kites in your head and like the pieces of wood that go in between them, you can get the idea here. Number 14, given a quadrilateral W, X, Y, Z. Remember, when you draw your quadrilateral, which cannot be determined, used to determine whether or not it's a rectangle. Now, let's start by kind of drawing a rectangle. When we label the points, we're just going to pick a corner and we're going to call it the first point, or one of these points. We'll call it W. Now remember, you have to go around the circle to label all the rest. So if you want to just go around counterclockwise all the time, just go the same way. This is W, X, Y, Z. Okay? So if WX is parallel, right, to YZ, WZ is parallel to this, and one pair of sides, WX and YZ, right, are congruent. So if these sides are parallel and this set of sides is congruent, is that going to make it a rectangle? No. Remember, the 2 properties we're looking for here, right, it's a parallelogram and it's got these special things. All right angles, diagonals congruent, or just right angles is fine. Okay, WX is perpendicular to YZ, so this is a 90-degree angle, right? And then WZ is parallel to xy. So is that going to be enough? One set of sides parallel, and we have a right angle. Okay, is that going to be enough? And the answer here is no, because I can draw this shape right here, right? So this is parallel, this is a right angle, this third side can still be whatever I want. So unfortunately, it's not going to be enough. Okay. Number 3, WX and YZ are parallel. WZ and XY are parallel. That makes it a parallelogram. And I have 2 sides that are congruent, right? WX is perpendicular to Y's. That can't happen. Well, that's interesting. Not possible. This should probably be WZ. We're going to change it to WZ because these 2 sides are opposite one another. There's no way WX, YZ. There's no way for WX to be perpendicular to YZ. So typo, switch it to WZ, and we got a choice. This would be okay. The third one, WX and YZ are parallel. Let's just check this fourth one out. Parallel. Okay. WZ and YZ are perpendicular. And then WX is congruent to YZ. Oh, this is the one. Get out of town with number 3. If this stays the same as YZ, there's no way for this to work, right? These 2 can't be perpendicular. That's why this is wrong. So I switch it. If these 2 sides are parallel and congruent, that makes it a parallelogram with a right angle. That makes it a rectangle. So if we change this to the other side, we had opposite sides parallel with a set of perpendicular sides. That would be a rectangle. But if this is YZ, there's no way for that to happen. All right. Now, number 18 is just a graph. So we want to graph the points. 3, -4. If you have something come up and it's not working, make sure you go back and check that you graph this correctly. That's kind of one of the easy mistakes you'll kind of get hung up on. Remember, if you do the graph and you do it on the exam and you kind of mess it up and you did it in pen, remember that you can ask for graph paper. And you can do the graph on the graph paper and attach it to your test or stick it in your test. That is okay. That's the only time that you actually can get extra paper is when you're doing that. I have a green pencil here, so let's use it. You guys can see that, all right. All right, now this type of graph here is one that we like because it's got some horizontal lines on it, so that makes it easy to do. So, what's the perimeter of this shape? Now we can count these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11. Now we know that the one down here is going to be the same thing because it says parallelogram and the opposite sides are congruent. And then we just need to do, the distance here. Now we can use Pythagorean Theorem on this graph. So I can count that this is 2, 2, 3, 4, 5, 6, 7, 8, 9. And this is 9, okay? And then that should actually not be 9, should it? What's this? Wait, over here. Woo! Hold on a minute. Caught it. Yeah, 5, -4. That is 9. Okay, so this is 9. So if we just do the Pythagorean Theorem, a squared plus b squared equals c squared. The 2 and the 9 are going to go in for a and b. So this is going to be the square root of 85. And then we can kind of add those together. So it's the square root of 85 plus the square root of 85. And then we have 11 plus 11. That's I'm on the wrong question again, people. Really? Okay. Oh. Okay, I'm mixing up questions here. Did you guys catch that? I'm sure you're probably yelling at the screen saying, what is this guy doing? But in 18, it asked which one of these it is. Now, if you count the distance, you can figure out, right? This is also 9 and 2, that the opposite sides are congruent. They are not perpendicular, though, because this is the slope of 0, and this is -9 over 2. So it is a parallelogram, but it's not a rectangle. So we want to do choice 2 here. Okay, for 22, we have vertices of 3, -2, 3, -2, 7, -4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, -6, 3. That's 1, 2, 3, 4, 5, 1, 2, 6, and then 1, -4. So this guy. So I really want to graph people. So what's the perimeter? Now, if you just count, you can kind of count this out for yourself here. So let's count this. This is going to be up to, over 2. You can kind of box this in. You guys remember doing the box method here, right? And then you can figure out the distances. So this is 2 and 2. This is 2 and 1, 2, 3, 4. This is 2 and 2 and 4 and 2. So if we just do 2 squared plus 2 squared is equal to c squared, this is going to be 8. And we can take the square root of that and simplify. This is 3 2's. So this is 2 radical 2. The other one was 4 squared plus 2 squared. This is the square root of 20. So this is 2, 2, and 5. And so this becomes 2 radical 5. So there's 2 of these and 2 of these. So 2 radical 2's plus 2 times 5 radical 2. And this is going to give you 4 radical 2 plus 10 radical 2. We didn't do this right. This is 2 radical 5, and that is not what I wrote down here. So this is going to be 4 radical 5. 4 radical 2, 4 radical 5. There's my answer. Now, when in doubt, there's 2 of these and 2 of these. You can just type this in, get a decimal, and see which one matches. All right. Number 31, given parallelogram EFGH, find the measure of angle FGH. Remember that the adjacent angles or consecutive angles are supplementary. So it's just 5x plus 2x plus 5 is equal to, let me just double check to make sure that that is the right number that I want to use. You're killing me, Smalls. Sorry, you want to make sure we're right here. It is 5x. Okay. Is equal to 180. This is 7x plus 5 is equal to 180. We minus the 5. We get 7x is equal to 175. We divide by 2, and x is equal to 5. That should be 25, right? There we go. And so that is angle FGH is this guy. So 5 times 25 is equal to 125. All right. And then the next guy, the parallelogram, we have AD, AE. So AD is 18, AE is x plus 5y, BC, which is this whole thing, is 4x plus 3y, and CE it says is 13. All right. Couple different things going on here. We need a couple equations here to solve for x and y. This is a systems of equation problem. This is a tough one. This is extra. We don't really need this. The key thing here is that we know what AE and CE are, right? And we know what AE and BC are. So remember that 2 times, remember these diagonals are going to bisect each other. So this is going to be equal to this, okay? And the diagonals, however, are not going to be equal. So that's going to be a little bit tougher here. But this is 13. BC is 4x. Oh, I labeled that wrong. 4x plus 3y. There we go. So this is necessary. So we know that AE is congruent to EC, And we also know that BC is congruent to AD. So opposite sides are congruent, the diagonals are cutting each other in half. That's going to help us set up these equations. So 5x plus 5y is equal to 13. And the other equation is 4x plus 3y is equal to 18. Now, you can either solve for one variable, right? And then plug it into the other equation. That's option 1, okay? Or option 2, we can stack the equations. So it's x plus 5y is equal to 13. And then 4x plus 3y is equal to 18. And we can just multiply to get one of the variables with the opposite coefficient. This is called the elimination method. So I'm going to go with elimination here. I'm going to multiply the top equation by -4. I'm not going to touch the bottom equation. So I'm going to get -4x minus 20y is equal to -52. And then this equation is just going to stay the same. And then I'm going to combine like terms. So I'm going to add straight down. The 4x's are going to cancel. This is going to give me -17y. And when I add 52 and 18, I bet you I get -34. And I do. And so when I divide by -17, I end up getting y is equal to -2. And now I can just plug that into either of the two equations. So we'll plug it back in here. So I get x plus 5 times -2 is equal to 13. This is x minus 10 is equal to 13. We add the 10, and we end up with x equaling 23. And so there's my two values for x and y. So that's just the systems of equations. Quick review for yourself, and you're good to go. I'm going to stop it here in this video. In a second, I'll make another one for this guy, and then we'll take a look at it.